Hello, and welcome to the Badger Talks podcast, the podcast that shares interviews with experts from the University of Wisconsin-Madison community about their work, research, and a little bit about what they're like as people, too. I'm your host, Buzz Kemper. Today, we'll be talking about the amazing world of whales, and I'm happy to have as my guest Dr. Alyson Fleming, Director of Public-Private Partnerships for the Nelson Institute for Environmental Studies. Dr. Alyson Fleming, or Allie, as I am privileged to call you, thanks for being here.
Thank you. Thanks for having me.
Yeah, so this is a big subject, pun intended. It's funny, when I read your bio, it said that, you're working in oceanography and you're dealing with the effects of climate change, and top predators was mentioned as part of your research. And I thought, I bet we're going to be talking about sharks. And it turns out we're going to be talking about whales. So, I think of whales as these big, gentle giants who, eat plankton and I just kind of like flash you the peace sign as you go by. But some of them are predators. So let's just get into a little bit of that. What is it? Only orcas, or what's the predator side of the whale world?
Yeah, great question. So often in marine science and oceanography, when we say top predators, sometimes we're even including seabirds, marine mammals, pinnipeds, which are like seals and sea lions, dolphins, whales, and sharks. All of those are often sort of referred to as top predators in the ocean.
Seals are considered top predators?
Yeah. So all of these,
they're
not the very top in some food chains. Sharks can certainly eat the seals, and some sharks prey upon certain types of whales as well. But they're all, large-bodied. They move across large areas of the ocean. They are apex predators, often at their food chain. They are often really social, long-lived. Many of them are returning to the same areas year after year, and they have these sort of ambits annually, daily, over many decades that create this strong presence and top-down forcing on ocean ecosystems. So sometimes we'll lump those together and say all top predators for those very distinct and diverse groups. But yeah, most of my research has focused on cetaceans, which are whales and dolphins, and those broadly fall into two large topics with our toothed whales and baleen whales.
Okay.
And so killer whales, dolphins, porpoises, sperm whales, they all have teeth. And then the really large whales, like blue whales, fin whales, humpback whales, they all have what's called baleen. And baleen allows them to be filter feeders. Okay. But it is, which sounds, as you said, give them the peace sign. It sounds very
they're vegetarians.
Genteel. Yeah. And they are in many ways, very peaceful. But when we think of filter feeding, that sounds rather passive or, low impact. But they are filter feeding at such massive scales, it's kind of hard for us to wrap our heads around the just size and capacity that these animals have for consumption. And even in what one gulp looks like for a blue whale is like parachute size.
Yeah.
And so it's just huge amounts, and they feed most of the time they are awake. And so even though they are feeding on tiny organisms, they're still such a force in the ecosystem because of their size and their need for calories.
And what are they feeding on primarily? Is it plants or small fish or everything they can get?
Yeah, it's varies for each type of whale. So humpback whales, fin whales, they're more flexible feeders. So they will feed on small fish and also plankton. And when we say plankton, in this case, we usually mean things like krill, which look like small shrimps, but much smaller than the ones we eat, that we have for our shrimp cocktail. But
how big are krill? Like is the tip of your little finger?
Yeah, they can be like maybe like one knuckle, or one thumbnail.
That's kind of
pretty
what I
small.
thought.
But in they can be much bigger. Like the ones in Antarctica are quite a lot bigger, and they look more like our shrimp cocktail size.
Okay.
So there's a range, but each type of baleen has really evolved over time to be best matched in its filtering capacity for the prey that animal wants to target. So humpback whale baleen feels and looks a little different than gray whales. Gray whales feed, they go down to the bottom, they suck up mud, and they eat what are called amphipods, which look like little crab kind of things.
Okay.
And so their baleen is really short and really coarse and like bristly, like the broom that you would use on your porch.
Okay.
Whereas humpback whale baleen, the bristles are finer.
Okay.
And if you think about even another type of whale like right whales in New England or bowhead whales off of Alaska, they have this really fine, spindly wisps on the end of their baleen, and their baleen is much longer. And those are built to be really good at filtering out the smallest of the animal plankton. And so they really sort of adapt. And so that broom would be more like, you know, a light brush that you would use like if you were excavating fossils or something,
wow,
you know?
are really good with the analogies. I love that. So the baleen, it seems to me counterintuitive, because isn't the baleen filtering out the stuff that they actually want to take in and consume?
Oh, good question. Yeah. So they open their mouths, most of them. There are a few different sort of styles of feeding for baleen whales, but most of them open their mouths wide around a large school of their prey, take that in. And so that might be like a bunch of jumping anchovies and sardines that are fast moving in the case of humpback whales, along with a lot of water. Or it might be these, you know, much more planktivorous organisms that are very slow and not very mobile. And then when they close their mouth almost all the way, their tongue forces the water out.
I see. Okay, I'm thinking of this backwards. I was thinking they're filtering on the way in. It's filtering on the way out.
Correct. They're filtering on the way out, so they get rid of the water and retain the prey behind those bristly bits of their baleen.
Wow, how did I get to this age and not know that? Okay,
well,
great.
You know, we're not all Pinocchio or Dory, right? Inside a whale's mouth.
Yeah, right,
figuring that out firsthand.
And what? Let me just. You mentioned the word cetacean.
Yeah.
What are the characteristics that define cetaceans?
Yeah, good question. So they're mammals. Okay. They really interestingly, actually, something I didn't learn. You know, I've had wanted to study whales since I was 6 years old, but I only learned much later in my career that marine mammals actually derived from land-based mammals. You know, we know sort of all life origins are in the sea.
Right.
But cetaceans are an interesting group that they are called secondary invaders of the ocean. So their lineage is actually organisms that look really much more like a dog.
Wow.
So the sort of earliest origin ancestor of whales today is something called Pakicetus, which looks very much like a dog and about the size of a normal household dog.
Okay.
And it's called Pakicetus because they were found in the area that is now known as Pakistan.
Oh, wow.
And over time, those land mammals started to take advantage of near-shore environments and move back into kind of what today we'd think of like an estuary or a marsh. And they started to realize that fish in those areas were good hunting. And they had, you know, those canine teeth that we know today. So they were good at grabbing things, but not very good at catching things that were faster moving than them in the water.
Okay.
But over 50 million years of evolution, you get from Pakicetus to a blue whale.
They got, and hence why they do not breathe through gills, but rather they have lungs and they have to
they have to come to the surface.
Wow.
Yeah. They lost their back limbs, they developed tails, they have lungs, they developed new filter feeding mechanisms for feeding in water, and they developed echolocation for communication underwater.
Okay. So if we manage, this is fascinating. So if we manage not to kill the planet in 50 million years from now, do you think that the lungs and the need for oxygen will change in these cetaceans, and they'll eventually become gill breathers?
Yeah, that's such an interesting theoretical question and a great sort of scientific hypothesis to think through of how does this lineage continue. And if we use the past as clues for thinking about that, what we see from that evolution from Pakicetus to blue whales is animals getting larger over time, animals becoming more adapted to the marine environment by becoming more streamlined in their physiology, by becoming more adapt to cold water so they don't lose as much heat, developing, as I said, new ways of communicating underwater, right? How we communicate air, sound travels very differently in air than it does in water.
Yes.
And but this one really unique aspect of whales that's been studied quite a bit in this sort of long-term evolutionary perspective is just how enormous they are, right? They are the largest organisms to ever live. And the size of whales over time has increased. So we are at the point in history where whales are the largest they have ever been.
And they're larger than the dinosaurs were.
Correct, yeah. And so I guess one question would be, would they keep getting bigger, or are we at kind of physiological maximums in different ways? And the reason that we think they have grown so big is there's multiple reasons. One, of course, water supports large weight, right? So you don't have the force of gravity.
Right.
Being large allows you to conserve heat. But the really large whales are the ones that migrate very long distances. And so they travel thousands of miles every year between their breeding and feeding grounds. And the thought of why they're so big and why they do that is because of global oceanography and climate patterns. And so in sort of deep time, thinking about how whales' size and characteristics evolved along with major changes in literally the shape of our continents and the shape of oceans and what the circulation of large currents that travel through all the world's oceans look like. Major changes in whale evolution occurred when, for instance, the Antarctic circumpolar current arrived, which is the current that goes all the way around Antarctica.
Okay.
It's strong, it's productive, it has a lot of upwelling, a lot of nutrients, and created these large reservoirs of food that were dependable at certain parts of the year.
It's a loop?
It's a loop,
okay.
yeah.
All right.
Yeah, so circumpolar, so it does this big circuit.
Okay.
And it's other places that we see these big important currents are like off of California or the Gulf Stream, which many people know about the Gulf Stream, off of Florida that goes all the way up to New England. And these very dependable, consistent currents have led to seasonally predictable quantities of food. And the whales know that it's there at that time.
Right.
And they don't just know because they've learned from their moms, which is part of it. They go each year, new babies travel with their moms to the feeding grounds and then back again. So they pass that knowledge down culturally.
Okay.
But also they have some kind of ecological senses that we are only just beginning to understand, where they show up when the prey is there. And these days, with changing climate and oceanographic patterns, there can be huge differences in the start of the feeding season of when is good food on the table. Sometimes it's in May, sometimes it's in June, sometimes there's a big blip in April, and yet they find it and they time their presence and their movements really well, and they seem to use information from previous years. And so there's something about their ability to detect this, and that predictable food source has only evolved over sort of millennial timescales with these predictable currents. And that's what we see. The increase in whale size really grew larger as those predictable global currents also sort of came to be.
Okay. Does size help with long distance travel?
Yes. Sorry, I should have said that. So if you are large size, you will be able to retain, they have a lot of fat on them. They store that energy. And the bigger you are, the less energy it takes to move a long distance, right? So
that
for
is
us
so
to move across a room versus a mouse.
Because if you or I were pushing a big rock, it would take a lot more energy than pushing a small rock. But in this case, being bigger actually then requires less energy.
Right. You conserve it. You can think of it more like, for us to walk across a room versus a mouse to scurry across that same distance.
Oh, that's true. It's fewer steps.
Fewer steps. Yeah. And we hold on. We don't have to move. If you think of a large whale, a few slow pumps of a tail gets them pretty far, especially when they're streamlined. And then they're not using as much energy, and they have a large body to store a lot of energy.
Okay.
Yeah.
Wow. So you mentioned the whale's amazing ability to follow these currents and be where the prey is at the right time. I imagine, though, that climate change is messing with those cycles, but the whales are still able to keep up with it. First of all, am I correct that climate change is is changing those cycles. And then secondly, are the whales adapting to that even? Wow.
Yeah, great question. Yes and no. So definitely climate change is changing those cycles. It changes what we call phenology, which is sort of the study of timing of things, right? So the timing of, the spring bloom.
It's literally phenology?
Yeah,
like
that's so... pH.
Oh,
P-H-E.
okay.
Yeah,
I was thinking, it's the study of fish who have fins. Okay,
no,
cool.
P-H-E-N.
Okay.
Yeah.
Or fish from Finland or something.
Yeah.
Okay, got it. Okay. Okay, sorry,
fish.
Go ahead.
So the timing of, like, if we look outside right now in Wisconsin, I have only lived here a few years, but I would guess people that have lived here a long time, they're probably noticing things like when the trees are blooming.
Yeah.
Right. And does that look different from maybe just last year because of weather? And does it look different from 10 years ago because of climate?
Yeah.
And these kind of, when things happen where?
Yeah.
And that's definitely happening in the ocean. That's changing. And many of the whale species do seem to be extremely adaptive and really sort of malleable in their patterns, both in terms of what they're eating, when they're eating, where they're eating. But there's differences. Some whales are really kind of these flexible foragers like humpback whales, and others like blue whales are pretty honed in to one type of making a living. And they only feed on krill, and they have pretty predictable spots.
Blue whales only eat krill.
The biggest organism only eats these tiny, tiny things. Yeah.
That is really interesting. Okay, yeah. And I thought they were kind of omnivorous. I thought wow.
No, somehow, then that's really where you see sort of these evolutionarily mind-blowing moments of like, how did this organism that is so specific and, kind of a real species of routine, right?
Yeah.
How did they get so big eating such tiny organisms? But they have just refined that methodology to absolutely like living at sort of the tip of this capacity.
Yeah, you would think that specificity of that type, that like you only eat one thing, you would think
risky.
that would be, from an evolutionary standpoint, you would think that would be a bad thing.
Yeah, they've become a real specialist, right?
Okay, yeah.
But I think what many studies are showing is that those specialists are then the most at risk for these climate changes.
Okay.
So if you are a humpback whale and you can eat 5 different things, and those 5 different things vary year to year, it's kind of like we hear, diversify your investments, right?
Yeah.
Humpback whales are doing that.
Yeah.
And so we see them even showing up in new places where there weren't many of them before, because they can change where they're going, when they're going, and what they're eating. Whereas a blue whale has to do really more the what and where.
Yeah.
It can't do, when and where. It can't do as much of the change of what it's eating.
Okay.
So I think we often hear in the scientific literature sort of like winners and losers with climate change. And so certain species will find new habitats and see an expansion of their range, and others will become more and more kind of, up against between a rock and a hard place and not have many options. And we see that showing up, evidence for that kind of shows up in moments like if there's a series of stranding events, or what we call mass mortality events, where many of them will die in one season because of a specific ecological shift.
Okay.
Yeah.
What are you finding in your research in terms of how, I'm sure there are many ways in which climate change are affecting these whales, but is there a big one or two that are like the big red flags, and or is that not the case? Is it a bunch of stuff?
Yeah, it's a good question. The big red flags that we see today usually are climate change plus something else.
Okay.
Plus some other human anthropogenic impact. So it's usually the combination of climate change plus, let's say, fishing. Or climate change plus shipping. So there's a few major categories of threats to whales today. We've, of course, we don't have a lot of whaling anymore, right?
Yeah.
Active hunting of them. But there's still, obviously, fishing has only, if anything, increased over time, right?
Yeah.
And the ways that we do that, and the type of gear that we use, and how far our presence reaches out into the ocean, right?
Yeah.
Just 200 years ago, we still were mostly coastal fishers, right? We didn't go very far.
Right.
But now we are everywhere.
Yeah. Now there's
and the
almost
nets
no
are
limit.
giant, and they stay out for, days, weeks, months at a time sometimes. So certainly entanglements and interactions with fishing gear is a big issue, and so is shipping. I recently saw in a presentation a map of like air travel, like 50 years ago versus air travel today, and that looks so different. And that's the same with shipping. Shipping now, the presence of ships and noise and drilling and platforms and tankers and just all this activity at sea creates a different soundscape, a different landscape, a different potential for interaction and being run over, literally. So often it's kind of like, well, a bunch of whales were moved into this area because this was good feeding, and it was, because of a change with weather and climate, we saw a lot of whales in this one area at that one time, but that also happened to be right in the middle of a major shipping zone.
Right.
Then that's a bad recipe, right? Then we see a few more deaths that year than the population can withstand.
Okay.
And
they
so
literally
it's
get hit
combo.
by ships, or
they do,
or by propellers or something.
Yeah, often just the front of the ship. Sometimes propellers, both.
Wow. And we would love to think that with most nations banning whaling, that, whales are safe now, but it's just not that simple. Are there still countries that have commercial whaling?
There are, and including ourselves. So definitely certain, we have a few different indigenous populations that still whale. That's a really important part of their cultural and caloric tradition. It's really still very much for consumption and
Inuit people, or
Inuit, exactly. Yep. And there's different indigenous groups across the world that still practice it in different ways.
Okay.
And then, of course, there's always sort of this, ongoing international conversations with Japan and Iceland are two of the countries that still conduct modern, sort of more commercial whaling, which many countries object to.
Interesting. I would think, I would have thought Iceland would have, they seem so progressive in so many other ways.
In many ways,
Yeah, interesting. Wow.
Yeah.
There's a couple more things I want to get into before we completely abuse your time. But one is, and we talked about this a little bit off mic, but what got young Alyson into this whole thing? You had a moment, right?
I did have one particular moment. So I grew up in Boston, so much closer to the coast. And I did, I can remember in like grade school getting to go on one or two whale watches and having that really stick with me. But it was really a second grade curriculum segment that we had in our class that was all about whales. And as part of that, we had a special treat on like Fridays that I remember getting to watch a PBS after school special that was called The Voyage of the Mimi. And it was this educational mini series, which starred a very young Ben Affleck. I think he was about 9 years old in it.
Oh,
and
wow.
So it's still on YouTube. I think you could, if you're interested.
Okay.
Really good 1980s.
What is the Mimi? What does Mimi mean?
Mimi was a ship, a sailing ship. And the premise of the show was it was a small group of scientists on board a sailing ship, the Mimi, who were traveling up and down the U.S. East Coast to search for humpback whales. And at the time, there were not that many. This was in the 1980s. There weren't. Yeah. The populations really hadn't rebounded that much from whaling at the time. Now those populations are much larger. Yeah. But the premise was that they wanted to take photographs of the underside of the fluke, the tail, which acts like a fingerprint. All of those designs, patterns,
they're all unique.
They're all unique, exactly. Yeah. So we can track individual whales, which then allows you to create family trees over time, which then allows you to know how many individual whales are in that population, who's having babies, how fast they're reproducing, all of those really fundamental questions. And I watched this in second grade and I just was like, that's it.
That's it.
Want to do that.
Yeah, and how many, that's really remarkable because we all did that as second graders, found the thing we wanted to do. But I think 99% of kids, end up on a completely different road.
Yeah.
Kids who wanted to be firefighters end up being, accountants or something. But you stuck with it. That's great.
Well, or I just stuck as a 6-year-old, right?
Yeah.
I never matured in my ideas of what a cool career could be.
And you're right. It is a cool career. Now, I know that you mainly deal with oceanography and you deal with these large apex predators and mostly whales. But can we talk a little bit about the limnology, the lakes of Wisconsin, particularly? What is being learned about climate change affecting our
local
lakes, especially the Great Lakes?
Yeah. So there's certainly a huge difference. Often when people meet me and they're like, what are you doing in Wisconsin studying whales? Oh, are you going to study the lakes is always sort of the next question.
Yeah, of course.
And I'm always like, no, because oceans and lakes are so fundamentally different. You know, a lake, even the large lakes, I mean, they certainly have more similarities to oceans, but the scale is so different.
Yeah, we don't have whales, we don't have salt water.
Yeah,
I mean, I realize it's a completely different universe.
But there are certainly some similarities. Like, you know, there's many people here study eutrophication, which is additional nutrients that have gone into our lakes, often associated with, you know, runoff from agricultural or lots of different applications on land. Those issues definitely face the ocean too, sometimes, again, at a different scale. Like, for instance, where the Mississippi River runs into the sea in the Gulf.
Yeah.
We'll just leave it at that.
Yes,
in the Gulf,
right. Yeah.
Then that has just an immense amount
of
nutrients.
We can say Gulf of Mexico. I'm totally on board with that. Yeah.
The Gulf that is south of
yes, right.
of us here. There's lots of nutrients going down the Mississippi and then entering the ocean. And the processes that we see there, because of that additional nitrogen and other nutrients, then leads to blooms of algae at large scales. And those blooms of algae, depending on, again, back to phenology, depending on the timing of that, it can become... If you have too much algae blooming at once, the rest of the ecosystem doesn't absorb that in a way, right? It doesn't kind of propagate up the food chain enough so that then you have these sort of large die-offs, and that creates deoxygenation of the water, like it removes oxygen from the water. Yeah. Those same things happen in the lakes here.
Okay.
A big piece that is sort of fundamental oceanography 101 is that a lot of productivity in the ocean, like what drives biological productivity, is nutrients coming up from below. Often when I'm teaching sort of introductory classes, you know, if you think of what grows a plant on land, water, soil, sun, right? In the ocean, obviously you've got the water, no problem.
Yeah, no problem there.
You have to be close to the surface to get the sunlight.
Right.
Where do the nutrients, the soil comes from, is from deep down, right?
Okay.
So even when you're close to the shore, you still need that mud and nutrients and sediment from below to come up to be at the level where the sunlight is accessible to. And that's what gives you those three ingredients. And so the upwelling in the ocean is driven by currents, and in the lakes, we have some of those same physical dynamics. You need the upwelling, but what causes that in lakes is, you know, changes in density and temperature, and a lot of that is really primarily driven by temperature changes over seasons in lakes, whereas in the ocean, temperature changes are playing out at much larger scales and longer time scales as well. So slight differences, but certainly lakes can be good kind of experimental grounds for us to understand those basic physical forcings that happen even in large oceans.
Okay,
too.
so algal, is it algal or algal? How does one say that? Blooms?
Yeah, I say algal.
Algal blooms, yeah. So that those happen in both
Definitely.
lakes and oceans. Okay, great.
And those are small plants,
okay. What can we do as individuals to just help the planet, you know, as much as we can, especially, you know, these problems with oceans, climate change? Are there steps that we can take? I always like to give people, like, here's a thing you can do, other than just, you know, recycling the obvious stuff.
Yeah. I mean, I think, you know, we always sort of hear often those lists of things like that we can do in our own homes or with our own diets or with our travel patterns or shopping decisions and things like that. I am, which I agree with all of those certainly, but I'm sure people have heard those, so I won't spend time kind of rehashing those. But I think the biggest piece, honestly, is if you care, you'll do something. And I think that often, you know, the if you care is if you're curious, if you're interested in something.
Okay.
And so to me, that's why education and things like field trips or things like
Yeah.
educational mini series, things that seem kind of inconsequential, watching,
Right.
I have 2 young kids and watching what they get excited about.
Yeah.
It's hard to predict, right?
Yeah.
And sometimes it might be like a book or one trip to a planetarium,
Yeah.
right? Or something that you think it's not really a big deal, but you never know what gets them hooked.
Right.
And even as adults, we have so many things on our plate, so many pulls in different directions. If there's a particular issue that we care about, I think that's what drives action. So it's
Yeah.
not so much maybe which of these decisions is the easiest, but if you care enough about something, then I think you kind of you're more motivated to make those changes.
I really like that answer. Yeah, the solution is you have to care, and in order to care, you need the knowledge of
Yeah.
what's going on.
Right,
And
to be
so
that
just
curious. Yeah.
just be
Ask
be,
questions.
be informed, and that'll provide you with a path forward.
Exactly.
I love that.
And whales seem so far away here in Wisconsin,
Right,
right? But if
right.
it's whales for you, that matters too, because we are,
Yeah.
all the world's water and atmosphere is connected. What we do here still impacts whales, thousands of miles away.
Yeah. 2 more just quick questions. One is just a wrap up. Is there anything you would like to say about your research or about any of this stuff, but maybe I didn't ask the right question to get to?
Well, you ask great questions, but when we were talking right before the show, you were also asking sort of, these other pieces that are kind of Wisconsin relevant. And one thing that's been really fun for me recently, the last 10 years or so of my research has all been based on museum collections.
Right.
And I'll just explain that briefly because I think it's, fascinating to people in terms of where the
that's right, the found whale parts. Yeah.
where we can sort of learn new information, and that includes here in Wisconsin at museums and collections here. But obviously whaling for centuries, our own whaling efforts for centuries, brought lots of whale material onto land, right? And
Yeah.
we used to use, before plastic was invented, we used baleen as basically the closest thing to plastic. If you ever get to feel baleen, it really feels like kind of a bendy piece of plastic, something you'd use like for a kid's dinner plate or something of that consistency.
Yeah.
And so it was a very hardy, useful material, and it was used for umbrellas, it was used for corsets, it was used for all sorts of things. And so there's remnants of that, thousands, maybe millions of remnants of that around the world's museums and sometimes in people's attics and storage units. And for hundreds of years, we didn't really ever study those pieces. We were using them in a utilitarian way.
Right.
But now with modern molecular analytical methods and ever expanding repertoire of scientific capacity, we have come up with all these new ways of looking at this old stuff.
Yeah.
And that old stuff is now revealing really fascinating information about what the world's oceans looked like 50 years ago, 100, 150 years ago, thousands,
changes.
millions
You
of
can
years
study
ago.
changes over time.
We can study changes over time if we have enough of those pieces of whales to string together time series, which are some of the research that I do. Or if it's a really, ancient sample of something prehistoric, you can understand, how different those prehistoric oceans were than today. They are like little time portals into that ocean of that time. And if we put those together, we can really understand better, what does today look like compared to what it used to look like 50 years ago, 150 years ago. And the thing that's most exciting to me on all of that is actually using those samples to understand the role that the whales had in the oceans of 100 and 200 years ago when there were so many more of them, in the same way that it's hard for us to picture like what Madison streets looked like 200 years ago. It's also really impossible for us to imagine what the world's oceans looked like 200 years ago.
Right.
And, you mentioned going on a whale watch, and you did get to see some.
Yeah.
Hundreds of years ago, you would have seen a lot more.
Yeah, I'm sure.
And we don't even sort of comprehend then how much impact those whales had on those ecosystems because they seem to us so special and rare, but they actually fundamentally change those ecosystems at biogeochemical levels by like how they fed, where they pooped.
Yeah.
All of that mattered.
Wow.
So we can
All
discover
right,
that
so
now.
everybody who's listening to this, check your grandpa's attic and see if there are any Pakicetus parts hanging out up
really
there.
special.
That would be really amazing. Okay, we probably won't find that. And finally, Allie, just what do you do in your spare time? You have kids, so I know that I've heard that children require some time. Just heard a rumor.
They do.
But do you have any hobby? What do you do for fun?
Yeah. Oh, well, young mom, 2 kids with a job, not a ton of spare time, but I love reading. We moved to Madison just a few years ago, so I love just, we're spending lots of time on bikes and exploring the town, and there's so much to do here.
Nice.
And yeah, there's always at the university, the other piece of being there that's so fun is my job these days involves a lot of partnership building.
Yeah.
And so I get to learn about new things happening on campus all the time, and I'm almost every single day, but definitely every week, I learn of a new whole department we have or whole area of research.
Yeah.
And that just feels like such a treat to be like, wow, I didn't even see what was behind door number 3, you know?
And that's
that
what this show is for me. I've been doing this for about a little over a year, I guess, almost a year and a half. And I'm just discovering all kinds of stuff. It's making me smarter, which is really,
and
really
it's in
awesome.
such that sort of true Wisconsin humble, right? Like people here are not braggy, and it's just amazing all of the sort of capacity and special talent we have here is really awesome.
Yeah, it is great. Alyson Fleming, thank you so much. This has been really enlightening. I kind of wish this was part 1 of a series because I feel like there's so much more we could talk about.
Well, thanks for having me. It's very fun.
You've been listening to the Badger Talks podcast. I hope you enjoyed my conversation with Dr. Alyson Fleming, Director of Public-Private Partnerships for the Nelson Institute for Environmental Studies. Please browse our previous episodes for other topics that may be of interest to you. The Badger Talks podcast is a creation of UW Connects and produced at Audio for the Arts Recording Studio in Madison, Wisconsin. Our music is composed by Bill Purdy and performed by the UW Marching Band. I'm Buzz Kemper. Thank you for listening.